Okay, so what we built on yesterday. If this is just F, what do I have right here on F? I've got a local max Y.
Positive F prime goes from positive to negative.
F prime changed from positive to negative. We can't say it, right? F prime changed from positive to negative. What do I have here? Min, because F prime changes from negative to positive. Love it. You guys, what do we have? What is my function doing here? It's concave down, frowny, sad, right? Frowny face. What is F prime doing here? I'm sorry, my function is concave up here because it's happy. Yeah, it looks like a happy face. Okay. So what we're going to learn today is what this point right here is called. This is called a point of inflection. And I've got the little definition down here. We'll get to it. You don't have to write anything down right now. This is called a point of inflection because what did we do? We changed concavity is how we'd say that. We changed concavity. Yep. So yesterday, what did we find out concavity was? If this is concave down, what's my second derivative here?
Less than 0.
My second derivative is less than 0 there. And again, we'll write this out. What's my second derivative here? Great. So for a point of inflection, my second derivative just has to change signs. And that's what we're going to say here. A point of inflection occurs where a function changes from concave up or concave down or vice versa. Let's just say it's when my F double prime changes signs. That's what we're dealing with today. Okay, here we go. Let's look at this graph. This is a graph of F. This is a graph of F. What do we have right here?
A local max.
We got our max, right? Okay, but let's focus today on this whole concave up and concave down thing. So if I were you with just a pencil, I might outline this guy. And what would we say about this? Concave up or concave down there? Concave down, and I might write it like that. What does that mean with my second derivative?
Less than 0.
F double prime is less than 0. Good. Then maybe since I don't have a nice, cute little highlighter, maybe if I were you, I would do this and kind of squiggle. This is now where it's concave up. F double prime is beautiful. And then,
Concave down.
oh, okay, you did not read my mind. What do I have right here then?
EOI.
This is where we have a point of inflection because we changed concavity or my F double prime changes signs. So maybe just write yourself a little bit of that. Graham Nels, what's it got here?
Concave down.
Concave down, agreed. And do we have another point of inflection?
Yes.
No.
Yes.
No.
We do know because my F double prime changed from positive to negative. We do have another one. Okay, so now what happens if we don't have the graphing calculator? What if it says, hey, where do we have a point of inflection? A point of inflection, one more time, is where that second derivative changes signs. What's up, Stevie?
You have to do equal 0 and then sign for it.
Exactly. Let's go see where this... Oh, did I give you F prime? You welcome.
Give us F double prime.
Oh, yeah. That's what I meant to say. Where does F double prime equal 0?
0.
0.
1.
-1.
2.
And
2. Notice this answer that Graham Nelson's going to be excited to choose, and then we're going to say it's not the right answer.
No.
Right? Those are all just the critical points. Stevie's like, okay, those are my critical points. Is my F double prime ever undefined?
Yes.
There's no denominator, so we don't have to worry about where that's undefined. So we're going to go throw these on the chart, y'all. We got a -1, we got a 0, and a 2. So we're just building on what we've done this chart with F primes before. We're doing the same thing as F double primes. A point of inflection was where the F double prime changes signs. What's the number we want to try smaller than -1?
-2.
All right. -2 or -3, don't care. Between them?
-0.5.
-0.5, bigger?
1.
Biggest?
5.
3.
Woo, 5, you went crazy. You guys, in order to figure out where my F double prime changes signs,
5, it's negative.
wait, real fast. When I plug in -2 right here,
It's going to be negative.
do I have to worry about this?
No.
I don't have to worry about anything square. It's going to be positive. So a negative times a negative
Positive.
Is
Times
positive.
is positive.
positive. If F double prime is positive, whew, we're so happy. We're so happy.
And then the next one is negative.
Negative times a positive would be negative.
It's negative.
Sorry.
Yeah, I think you said what you were not thinking. Yeah.
That's the point of inflection.
Ooh, because my F double prime changed signs? What about at 1? 1 times 2 is going to be positive.
So there's another point.
You're saying beyond it, F. Okay. So how many points of inflection would I have? How many times did my F double prime change signs? It happened at -1 and at 0. I dig it. Let's go do this guy. It says, what is the x coordinate of the point of inflection? Point of inflection is where that second derivative changes
I
signs.
was playing Fortnite.
Here we go. Go give me the first derivative.
X squared plus 10x.
Daria, appreciate you. Second derivative.
Oh, man.
X squared plus
Well, welcome to the party. Now we're...
double prime. 2x plus 10.
You guys, a point of inflection. In order to figure out where something changes signs, we got to figure out where my second derivative equals 0 or is undefined. Is this ever going to be undefined? Never going to be undefined. And it equals 0 at -5.
Chart it.
Thanks, Michael.
So you guys, my answer is either going to be D or E. Would you agree?
Yeah.
Just because we have a critical point doesn't mean we have to have a point of inflection. So, if we're at -5,
Why are you doing that?
give me a number smaller than -5. Thanks, Daria. You're the only one keeping me sane right now. Bigger than -5?
-4.
Oh, I like 1. I'm down with 1 or 0. Or all of them are right. Whew. People, we got to go plug those into my second derivative.
That's a
Concave
negative.
down.
Negative, concave down.
Positive, concave up.
1 in there would get me a positive, concave up.
Say it's probably
Do we have a point of inflection then? Yeah, because my F double prime did change signs. What if my answer was like this? What if my answer was like this?
got an issue.
Well, then we have no points.
Then we'd have no points of inflection. That's okay. You want to know what that would look like in a graph? Is this graph concave down, then concave down?
Yes.
That's what this would look like if that was our answer. Okay? This number 78 says, hey, here's F double prime. How many points of inflection do we have? We're looking where my second derivative changes signs. Let's go graph that second derivative. You guys, if you graph that second derivative, sine of 3x minus the cosine of x squared, change your window to 0 to 3.
Did you see the reverse car wash yesterday?
Yeah, they've been doing that. I love it.
It's kind of tough.
1. So I'm going to go also change my y min to -1,
We're gonna have time for a crossword.
my y max to 1.
Oh, yep, that's a point of inflection.
Now I would say sketch this out real fast, you guys. Just throw yourself a sketch. And we got a little bit of woo. We got a little bit of woo, woo, woo.
No, it's
Okay. If this is a graph of F double prime,
whoa.
where does F double prime change signs?
5 times.
What is F double prime values here?
Negative.
Negative. What is F double prime here? So aren't we looking for all these times?
Minus cosine x squared.
Yeah. Did you put a -1?
Zero.
Wait. Oh.
We're scooting. You guys, this guy, I do like this one.
Non-calculator.
Non-calc. If we're asking for a point of inflection. So point of inflection is when my F double prime changes signs.
Find the derivative.
They didn't give you F double prime. Let's go, Stevie. Don't worry about it. F double prime is 3x squared
Minus 4.
minus 4.
Set it equals.
Set it equal to 0. No. X squared equals 4/3. X is plus or minus
2 root
3x squared minus 4. So 4 equals 3x squared. So 4/3 equals x.
So the -1's not in here. Did they give us an option of is there
No non-point.
there's no point of inflection as an option as an answer. So meaning points of inflection happen when my second derivative equals 0, which is here, or when my second derivative is undefined.
Can only be the critical point.
Agreed, because yeah.
Excuse me?
Here we go. Check out what they said in 2013, 10 years ago.
I got this.
They said, where does F change from concave down to concave up?
F double prime. Point of inflection.
So we're looking for when F double prime changes from what to what, because here they're specific. They want from down to up. Yeah. So we're looking from F double prime changes from negative to positive. Let's go find F double prime. We don't get a calculator.
F prime.
What's F prime?
Cosine.
Of X
X.
minus sign.
Minus the sign. Now here's where we went wrong in my last class. Derivative of that.
Double prime. Is negative sign.
Yes?
Minus cosine.
Nice. Thanks, Lila. Derivative of negative sign is still negative cosine. Guys, we got to go set that equal to 0.
I don't like doing
Okay.
it.
I don't blame you. That's why I wanted to practice it.
I'm glad we're practicing it.
Equals cosine.
Yeah, he said, let's just bop that negative cosine to the other side to make it positive cosine. And then we got to think about the unit circle.
Okay.
When does sine equal the opposite of cosine?
Oh.
Yeah, so when does sine, let's make them positive. When does sine equal cosine?
3 root.
When does sine equal cosine?
My
At what radian? At pi over 4.
Pi over 4.
So at
7.
3 pi over 4, they're opposites. 5 pi over 4, they're both negative. 7 pi over 4, they're both opposites again.
And we use the opposites again.
Because when does the cosine equal the negative sign? Yep. So we're going to say that's going to be at 3 pi over 4 and 7 pi over 4. Why do I not need to keep going? Because look at this domain bound that they gave us. They said stop at a full rotation. So you guys, is my second derivative ever undefined?
No.
No.
Nah. So these are the only critical points we're going to put on our chart. 3 pi over 4 and 7 pi over 4.
5/6 is long.
It is. You want to know why? It's honestly, we've covered all the content. They just cover this a lot on the AP test that I had so many practice problems I wanted to give you. Does that make sense? There's no more new stuff I've got to do. I just wanted to practice it with you because they hit it a lot. You're saying let's go 0 between 3 pi over 4 and 7 pi over 4?
The sign chart this?
Yeah. Let's keep it in terms of radians. So instead of 1, could we say 1 pi?
Over 4.
5.
Could we even just go, if here's 3 pi over 4, there's a pi,
2 pi.
and then bigger than 7 pi over 4 within our range domain would be 2 pi? You guys, you always have to plug these into your second derivative to figure out about concavity. This is good unit circle review. At 0 radians, here's 0, here's pi, here's 2 pi. At 0 radians, what's the sign?
0.
Good, the y is 0. What's up, Shamey?
You don't have to.
So if I plug in a 0 here, we had 0 minus, cosine of 0 is 1, so that's going to be 0 minus 1 is negative.
Sign of pi.
One sec, because f double prime is negative, that means my function is concave down. The sign at pi is 0 minus the cosine over there. Minus negative 1
Plus
is positive, so concave up.
I'm just making a sound effect. That's
It's
not
3
a
pi
quack.
over 4. It's B.
I promise that's not a quack.
I got you. When we come back to 2 pi, we're back at 0.
It's gonna be
So
the
is
same.
0 minus 1 would be negative 1.
But it's negative positive. So
We want from concave down to concave up, negative to positive, so we're talking at 3 pi over 4.
Let's go.
As we look at this one, it's calculator active, bless up. Let's go look at what it says. They gave us f prime. They said, all right, let's talk about maxes and mins.
Can you find F double prime?
Well, not necessarily for maxes and mins, right? What makes, if this is my function, you guys, if this is f, what makes that a max?
F prime is
Negative.
positive.
F prime goes from positive to negative. So can I go look at my graph of f prime to go see these maxes and mins potentially? Let's go graph f prime. That f prime is the sign.
I mean, change
Of x
the
squared.
window.
We got to change the window from 0.4
2.4.
to 2.4. My y min and my y max are still negative 1 to 1, and I feel good about it.
As a relative max and min.
Well, we graphed f prime though, bud. We graphed f prime, right? If I was looking at, if this was a graph of a function,
So that's at a little less than
Concave
2.
down and then.
hold up. We're all saying a lot of things, and I feel bad for Carrie who's got to watch this video. So, real fast.
0.
We're talking,
11.
shh, my goodness. Okay,
It's a 0.
Negative.
Because this is f prime. Here we go. Because this is a graph of f prime.
0.
For my maximum, my f prime has to go from positive to negative. Is that here to there? What would we have up here?
It's a max.
If I was looking at a function, what is my, if I looked at the slope here, what am I actually talking about? F double prime. I don't, for a maximum, my f prime has to go from positive to negative. And it does here, right? So we don't even care where that is, but I agree that happens. Do we have a minimum anywhere? For a function to have a minimum, wouldn't my f prime have to go from negative to positive? My f prime does not go from negative to positive anywhere, so I'm not down with 2. Here's the new part as of today. A point of inflection is when my f double prime changes signs.
It does twice.
That's when the slope.
1 and 3.
Thank you. Dicey's saying we got to go look at the slope of f prime to get f double prime. What's my slope of f prime here? What's it here? Negative. So you guys, on your sheet, I would write that's a point of inflection. This messes with our head because on a graph of f, that's a maximum. That's not the graph of f. Agreed. So then what's my f prime here? F double prime here.
Negative.
What's my f double prime here?
Positive.
So what do I have here? This is another point of inflection.
I'd say it's D.
But this messes with our head because if you were looking at a graph of f, these would be mins and maxes. But I agree with 3, so I'm down with 1 and 3. We're skipping. Yeah, I want to go to
2012 AP test, calculator.
right here.
How about 3?
I want to make sure we're down with our verbiage. Down with our verbiage. Graph of f prime. This is a graph of f prime that is very important. It says, where is f concave down? Let's write out our rationale before we even look at the graph. Concave down means
F prime changes.
f double prime
Is less than 0.
is less than 0. If they asked where my function was decreasing, that'd be where f prime is less than 0. This just got you a point. Say that again, Sammy. It's the slope of f prime is f double prime, right?
Be negative.
Ooh, what's my slope of f prime here?
Negative.
Negative. What's my slope of f prime here?
Negative.
Negative.
So is f double prime negative that whole time?
Yes.
Miss Soph, f prime was positive there. Good. What's f double prime over here?
Positive.
Positive, so we don't care about that.
Negative. Negative.
F double prime,
Yes.
and then do we care about over here? No. So what would we say my intervals are?
-2 to 0.
-2 to 0 and
4 to 6.
done. Let me say this one more time. They said, where is my graph of f? Where is my function? Concave down. We know that's whenever my second derivative is negative. My second derivative is the slope of f prime.